Hi, today I want to talk about a scale I just came across, discovered, formed by ascending into the higher non-prime harmonics following the 5 series. 5 series is all of the multiples of 5, 5, 10, 15, 20, 25, 30, etc. And because it goes through every multiple, it will involve all of the harmonics of the harmonic series. So 5 times 7, this will be related to a 7-limit interval because it's formed of a 5 over a 7. So you go to the 7th harmonic, and above that you have a major third. Every multiple in the 5 series is a major third above another partial within the harmonic series. Think about the 15th harmonic. The 15th harmonic is a 5th above the 3rd. 3 times 5 is 15. 3 representing the perfect 5th, and 5 the major 3rd. Pythagorean tuning is a 3-limit series that uses the higher overtones, such as 243 over 128, 81 over 64, and 27 over 16. We know that we have an interval of the harmonic series, and in this case, a higher non-prime interval, when the denominator is of the geometric series being 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, etc. So the multiples of 5 provide us with a unique series of intervals that are 5-limit intervals and oftentimes related to higher prime intervals, especially as we continue up in the series. So we start with 5, of course, which is just the major third. Then we have 10, but 10 over 8 reduces to 5 over 4, which is just a repetition, an octave higher of the major third. Then we have 15, which produces our major 7, 15 over 8. And then we have 20, which again will reduce down to 5 over 4. 25 over 16, the 25th harmonic. This is the lowest form of this fraction, 25 over 16. It is a minor 6th, formed by stacking 2 pure thirds, 5 over 4 times 5 over 4. 30 will give us reduced 15 over 8, major 7 again. Now 35 gives us another unique interval, irreducible in its fraction, 35 over 32. And this is a neutral second. It is the major third above the 7th partial. So 7 times 5 is 35. This is the mixture of 7 and 5-limit intervals. Next we have 40, which will reduce again to 5 over 4. 45, which gives us the 5-limit tritone. That is a pure third above the whole tone. So if we go up to the 9th partial and above it, we place a major third. That will be 45 over 32. 50 will, of course, reduce back to our 25 over 16, 25th harmonic. 55 is another now unique interval, which is formed by the major third above the 11th harmonic. And by now you've caught on to the pattern. We are just adding a major third to each partial and running the prime series through our combination of a major third. Now, for my scale, I'm only interested in the 5-limit intervals, so we can already see where the 15th harmonic and the 25th harmonic, the 15th harmonic will give us the 75, because 5 times 15 is 75. So the 75th harmonic, the 45th harmonic, and the 25th harmonic. And so this scale you could think of as being the 5-limit equivalent of Pythagorean. It maximizes the axis of the major third, tries to include as many major thirds as possible. And when you stack major thirds, you get this augmented chord. Mathematically, this is described as 16, 20, 25. It appears in our scale under the unison of 1/1, the major third of 5/4, and the 25th harmonic of 25/16. But it exists between several other chords within this. So instead of using your typical 5-limit minor sixths and sevenths, I'm using these higher non-prime harmonics like 25/16, 75/32, 45/32, 225/128. And what this gets us is 8 pure thirds, pure major thirds. We have 8 of them in the scale. And we have 5 minor thirds, 7 major sevenths, 3 minor sevenths, 5 major sixths, 8 minor sixths. And of course, the major third and the minor sixth are inversions, as are the minor third and major sixth. And this scale also does have a handful of Pythagorean intervals. So there are 2 minor thirds, there are 5 minor sevenths, and 2 major sixths. The scale also produces 8 wolf intervals, so 8 of our chords cannot form triads without being very out of tune. But the whole point of this tuning, in my mind, is to be used counterpunctually, where you're only using thirds, sevenths, and sixths. And the seconds and the fourths are much more amenable to the wolf intervals than are the fifths. 8 major thirds is a lot. That's 2 out of 3 of the thirds within the whole 12-tone scale is a pure third. So naturally, this tuning is very amenable to Bach or any counterpoint music that is modulating often, because this allows you to modulate and have major and minor thirds available, as well as their inversions, quite copiously from one key to another. And this scale is really well approximated by 53 equal divisions of the octave, and in that case you can modulate it on any axis you like. Here you are highly limited in the key relations of which chords are more in tune and which are less. And so when writing, you are led by the tone of each interval, and sometimes the note that you would want to put somewhere is actually the out of tune version. So in 53 equal temperament, you could easily modulate there, but here you are deterred from making certain chord changes because they're not in tune within the schematic of this 12-tone. So I'll just end by sharing this little piece that I wrote for piano, where I tried to explore its potential both for writing in counterpoint and using these augmented chords, and for modulating between a number of very consonant tonal centers and this very consonant whole tone series. So anyway, this is a really interesting scale. Let me know if you've encountered it before or if you end up using it in the future, and see you next time.